I'd like to welcome everybody to the Q&A session. It's probably going to be, hi, how are you, Sarah? Nice to see you. Um, anyway, I'm Dr. John, even though it says maybe my name's somebody else, but that's okay with this webinar stuff. Anyway, today what we're going to be doing, hello everybody, I just wanted to say, this is a real great opportunity of being able to present to you this series on methylation. Our first one was on methylation and genes, and genes and methylation, genes control the process of methylation. The human genome is responsible for controlling the methylation process. But today we're going to focus in on metabolism and the influence of methylation on metabolism, which is very, very interesting. It would be very complex, and you would think you need to have a real degree in biochemistry to understand it. But what we're going to do is we're just going to briefly touch upon the elements of methylation on metabolism. So if you have people that are struggling with continuous that you know of, if you're a professional out there with weight problems and they can't seem to shake it, or if you yourself are experiencing problems with blood sugar control and can't seem to get that glucose, can't break the insulin resistance, or you can't seem to shed the pounds very easily, or maybe it seems like you're more hypoglycemic. All of these different things affect methylation. And so what I'm going to do is I'm going to briefly show you, the process of methylation in itself is very complicated. And I just wanted to say, hey, this really great to see everybody here. So if everybody can hear, if you can hear me, please raise your hand and let me know. I'm trying to see if you can hear okay. Hold on a second. Now I'm clicking through the screens, and great. Everybody's saying you can hear me. So with a show of hands, right? Just raise your hand if you say you can hear me. And that little hand that's over there, yeah, very good. The only problem with this that we have is that it's in listening mode, right? So I can't take your questions by you asking them, because apparently there's a, a definite feedback problem when that happens. So, but you actually have the ability to ask questions. It says, you see on your dashboard, ask questions. You can actually send me those questions and type them in. So type your question in, and I'll answer that question as it comes up. But right now I'm just going to do an overview. Hopefully you can see me. I'm in, I'm in my office here. We're still doing some work in this new office that we just opened up a few weeks ago. So we're really, I can't see anybody. I only can, I'm talking to myself, or I can see myself, but I can't see you. But that's okay. No worries. When webinar gets really good, then be able to see everybody, and it'd be just impossible to be able to see everybody on their video. So, okay, so again, we're talking about methylation's influence on metabolism, and with that, it's being recorded, so you'll be able to listen back at this. Now, what I'm going to do is I'm sharing my screen, so hopefully, can all of you see my screen? Raise your hands if you can see the screen right now. Can you see the screen? Just raise your hand if you can see the screen. If you have a laptop, if you have a laptop or an iPad, there's several of you that can see the screen. If you can't see the screen well when I'm recording, it'll be actually coming on the screen, so you'll be able to see it then. Great. All right. So with that, I'm going to be putting up, something up on the board here. It's actually a few things that I think you're going to find very interesting. There are several articles that, hold on a second here. Okay. There are several articles, and there are a lot of different schematics out there that are really helpful. Now, what I'm doing right here is I'm pointing out to you that when we talk about methylation, methylation is the process of the body whereby it protects its healthy DNA. So, like, in other words, when we talk about a methylation process, we're trying to see integrated movement in human metabolism to whereby the metabolism is healthy to where the methylation is working smoothly. Now, there are many, many facets to metabolism, and a lot of you are probably aware of that there's glucose metabolism, which means how your body's burn sugar. There's protein metabolism, how well your body uses protein. Fat metabolism, amino acid metabolism. There's a neurotransmitter type metabolism. So there's a lot of different elements of human metabolism. And I'm showing you this chart right here because if you look at this chart, these are all the different gene controls that are responsible for directing metabolism. So when we actually go into it, you're saying, well, how in the world will we ever find out what the heck is going on when we locate a specific gene? Well, when you do your genetic test and you're actually profiling for areas of sensitivity, those genes will actually show you some windows into maybe faults in metabolism that are occurring. Okay, so from a very basic standpoint, and we don't have a lot of time to go into it, I just wanted to show you the genetic influence in human metabolism. As you can see, these genes right here are coded for movement into metabolism. So now, with that, what I wanted to do is remind you of the methylation cycle. So now, methylation in itself is a metabolic process. So, like in other words, methylation has different elements to it. I'm pointing my arrow here, as you can see. A lot of the time, a lot of the people out there who are professionals are focusing in on methionine metabolism, which involves, you've probably seen some things on your genetic reports like BHMT and MTRR and MTR and MTHFR and homocysteine. Some of these things probably ring a bell for you. And as you can see, there are different cofactors that are responsible for moving healthy methionine movement, okay? And it's going in a cyclical fashion here, but methylation in methionine metabolism influences not just the homocysteine. As you can see, we're moving into other areas. Here's the 5-methyl THF and the methylene THF, so that's the MTHFR pathways. Then you move all along here, and then you can see nitric oxide. You can see the urea cycle, which is involving Krebs. You can see a lot of the superoxide dismutase and the involvement in conversion. This is heavily where the glutathione pathways work, right in here. Okay, you can see the BH4 movement, the COMT movement down here, and then you can see some of the cofactors that are listed like SAMe and moving, things like COMT and DRD2 and the effects of that. The SAMe is directly helping with COMT. If you have a real strong double positive expression, sometimes SAMe can be used to actually facilitate better enzyme control and actually help with prefrontal clearance of dopamine. This is really important to know because when you look at metabolism, the methylation process in a whole is actually a process of metabolism, okay? And you got to realize that metabolism and methylation are integrated in. So if there's faults and issues with metabolism as a whole, of course there's going to be some issues with methylation process and the ability to help with good, healthy, regenerative movement of healthy DNA. So again, the genetic controls here, as you can see, and then the methylation controls here, which come down to the bottom line of if a person has a lot of inflammation, if they have difficulty with glucose use, if they can't break down their fats very well and they got high cholesterol, if they have the tendency to be inflamed and develop more inflammatory process in the body, if there's a lot of problems with antigen processing and immune integrity, all of those are going to affect metabolism and methylation. So you can see how integrated that they are. Now, here's the other thing, and then I'll get to your questions. The other thing here is that if we look at metabolism as a whole, this is a very good chart to go to. A lot of you say, well, how in the world will I understand this? But you know what? I get that. it's hard to understand. But the bottom line is that you're going to recognize a lot of different integrations here. Here's glucose, glucose and the glucose breaking down what they call anaerobic glycolysis into fructose and all the way down to the Krebs cycle here. Okay, these are all very important areas in generating energy. Okay, so if you have a shortfall somewhere in this metabolic pathway, methylation will be affected. Okay, if you can't break down your glucose, if you can't use your glucose, if you have an insulin resistance, bottom line is methylation is going to be affected somehow because it's integrated in with metabolism. And I wanted to just show you the relationship there as a whole. We can't get into all these details, but if you look at this and you study it, this is a very, very good chart for a person to look at. And the bottom line is, if you can't generate enough energy in the cycle in the cell, then your cells begin to suffer what they call cellular-based fatigue, poor mitochondrial management, can't generate enough ATPs. All of this is in that process of metabolism. So very, very important to note. And then there's a very good article on the impact of metabolism that was put out in 2005 that I found to be very, very interesting in giving the relationship of methyl groups and how methyl groups influence certain type of neurological disorders that are associated with metabolic loss of metabolic controls, not just homocysteine, but some other pathways as well. And the methionine cycle is actually explained in this article, but you can see this is another process of methylation cycle, but this is a very good article. It was written several years ago, but it's still very relevant. Another article that's excellent is this article right here. It's called Influence of Metabolism on Epigenetics and Disease. And I like this article because this is fairly recent. It's just only a few years old. And it's talking about the imprint of DNA methylation on metabolic movement and epigenetic signals. So like in other words, epigenetics is basically how do I turn the potentially bad influencing signals to better signals, turning bad genes off and good genes on. How do I get the body to make these changes? And are these changes really relevant? Do they really influence the body's ability to turn off bad signals? And there is a lot of research out there right now that's pointing in the direction that yes, there are many things that you can do, for instance, in cleaning up your diet and taking the bad things out of the diet, making sure that you don't have a lot of laden foods with residual toxic chemicals and waste products, things that are going to affect us from the environment, making sure that the antigen processing system of the immune system is not overloaded. And if you do have a problem processing antigenically, to really enhance your body's ability to process better. Because if you do, you're going to be encouraging some favorable cycles in influencing epigenetic signals for the best. This is a very good article. I encourage you to use it as a reference source. It's not really that difficult to understand. And if you have a science background, you would recognize some of the language. But bottom line is that metabolism and methylation processes in being able to influence epigenetic signals. Very, very important to know that. So with that, I would say I want to be able to, answer any questions that you may have. We have quite a few listeners. Looks like we've got, probably 101 attendees that it's listing here. So that's a lot of people. But the thing is some people will, sign up, and they also are waiting for probably the recording to come out. But now, please type in your question so I can answer that question for you. What are any questions that you may have? Can you still hear me? Raise your hand if you can still hear me. Yes, very good. If you don't know how to raise your hand, there's a little hand right there. Okay. Some questions, one person's question is, why do some people actually have problems with taking certain types of nutrients that contain methylated structures? Well, the interesting thing about individuals that are having a problem with methyl donor products, that's what they're called, they are not able to take these methyl donor products because maybe they have a problem with their catecholamine movement. Catechol methyltransferase, which is known as COMT, and some other type of methylation, BHMT, for instance, and SLC19A1. These are all genetic controls that would demonstrate a person's CBS is another one of those. CBS, you'll find people that actually have an excessive CBS and CTH. They basically are saying that the process of the methylation cycle, uh, when a person is taking a methylated product, could be driven too fast. And often what winds up happening in these situations is that a person usually starts off on a low dose, and then the practitioner will raise the dose up to a higher dose. And what winds up happening is that there's a signaling pathway in the methylation cycle that all of a sudden expedites and moves the methylation cycle really fast. And you may not notice an initial aggravating reaction when you first take, like, for instance, quaternary folate or a methylated B12 with a person that has COMT and BHMT and CBSs. You may not notice that initially. The thing is that when the product is taken over time, then all of a sudden the methylation cycle over revs, especially if the methylation is underexpressed, and then you wind up getting the concomitant neurotransmitter disturbances associated with it. So then you wind up finding that a person that winds up starting out initially okay, when they take it, they all of a sudden have a very bad aggravating experience later. They might experience like a super mood change where they go into maybe a depression, or they feel agitated, or their body feels wired. That means that the methylation cycle has kicked in to overdrive, and you got an undermethylating movement. If a person's coming in as an undermethylator, all of a sudden you provide these methyl donor products and you're revving up the methylation cycle and overcharging it. And see that it's not hard to do because of the fact that little small corrections go a long way with the biochemistry. When you actually try to overcorrect the biochemistry, it's not a good scene. So it's not a good thing for a person to think about. If a little bit is good, a lot's better, because that's not how the biochemistry works. The biochemistry works by small corrections. And remember that metabolic pathways that I showed you. I mean, when you're looking at it, here's the methylation cycle again, and then here's the genetic controls of that methylation cycle, and then you've got all of your metabolism. So your metabolism is so intricate that, yeah, okay, there might be some areas in metabolism that you're going to focus on to really help with enhancing, like, for instance, better glucose availability. So a lot of people will wind up taking more chromium, or they'll take a glucose tolerance factor chromium, or they'll take some trace minerals to assist, or maybe even some botanicals to really energize the uptake of glucose by working on the insulin pathways and also by energizing the Krebs cycle. So a lot of these things, like people that take NADH, for instance, or CoQ10, what do you think you're doing when you take those things? You are providing a cofactor that's going to energize the TCA cycle and actually put it into a good cyclical movement so that you have better energy production, and you're going to wind up using your glucose a lot better. So you're going to break the insulin resistance pattern, use the glucose better, because you're taking two super energy molecules. You're taking NADH and you're taking a CoQ10, which actually energizes, both of them energize the mitochondria of the cells. So if you energize mitochondria, you're doing a couple of different things. And a lot of you, I don't know if you know where the mitochondria is. If you want to know where the mitochondria is, we can go over to GeneCard. Let's go over to GeneCards really quick. and I'm going to show you where where the mitochondria is. Cell dynamics are really important. You're going to find that bottom line is that if you influence cell dynamics and energy, you're going to be doing a lot for yourself and your health. So we're going to be looking up MTHFR here as a gene, and a lot of you can sign up under this here to profile your genes. But I want to show you, okay, when you're actually looking at MTHFR, and we know that MTHFR is probably one of the biggest studied items right now and very controversial. So some people get really bent out of shape with MTHFR and they're saying, oh, well, MTHFR causes a whole mess of problems. Vascular disease, neurotube defects, cancers, et cetera, and bad methylation problems. Well, the methylene hydrofolate reductase, the methylene tetrahydrofolate reductase is a very important enzyme, but it's an enzyme system that's very essential in regulating energy pathways. And if you look at it, it's located on chromosome number 1, located on the short arm of the chromosome. It's approximately 21,198 base pairs long. So that means that if you have SNPs can insert themselves anywhere along that base pair path. And it's made up of a bunch of amino acids. And so the amino acids that are responsible for making this protein is there's quite a few different amino acids there. And if you look at it, 656 amino acids, as you can see right there. Okay. As we move on down here, we're going to go see where in the cell it's being produced. The cell actually has a bunch of MTHF in the cytoplasm. So as you look at the cell, you got the nucleus, you got the endoplasmic reticulum, the Golgi, the mitochondria, all of this. What does it mean? The nucleus has the engineers there. This is the endoplasmic reticulum is the manufacturing plant. The Golgi apparatus is actually the customer delivery center, packaging and processing and delivery. The mitochondria is the powerhouse of the cell. There's interface between the nucleus and the mitochondria. The DNA has its own set of genes. It has about 20,000 genes. 39 of them are command performance, high weight of evidence genes. They say that the mitochondria, most of those genes, as a matter of fact, some say that all of the genes are maternally inherited, okay? So now the bottom line is if you have good engineers in your nucleus and you have good engineering in the mitochondria, you're going to have a healthy cell turnout. That means your energy regulating pathways are going to be primo, and they're not going to be a problem there. Okay? And if you look at some other gene controls like the end of S's, so I'm going to just show you here that the end of S system is huge. When you look at end of S7, remember I talked about NADH as people taking like 5 milligrams a day to energize their mitochondria, and all of a sudden their blood sugar gets better and they get less insulin resistance and they seem to have a better energy profile. Well, look at this, NADH dehydrogenase. Where do you find it? Chromosome 19. How many base pairs? 12,063. How many amino acids? You got a bunch of amino acids there too, which is 213 amino acids, make it all up. And then let's go down to the cell. The cell, where is it being produced? In the mitochondria. So if you come back with a lot of end of S's that are yellow and reds, then you'd actually be saying to yourself, what is actually happening? My mother maternally inherited mitochondrial genes. If she had poor mitochondrial support movement in the cell, then most likely it's going to be passed down to the next generation. So if mom had bad mitochondria, there might be a possibility. If dad has a positive and a mom has a positive and you have a double positive, you're probably going to have some, maybe not as resilient mitochondria as you should. Because a lot of the times when we look at these mutations, when a positive mutation happens on a SNP in mitochondria, it usually is not one that favors necessarily a favorable change. Now, when we get down to SNPs, for instance, I want to just explain it to you. A SNP is a single nucleotide polymorphism. And a single nucleotide polymorphism, generally speaking, is not of any type of disease consequence normally. So it's non-consequential, usually. Now, however, there are times where you have the express changes upon a gene's performance, And some of these gene performance expressions cannot be necessarily gauged very well. So when we go back to the methylation pathways and the metabolism pathways, what we're really saying is if I have this gene that's showing possible underperformance, okay, and it's possibly affecting my methylation cycle, then what is it exactly doing? What is it doing? Is it causing my methylation to be subpar, where it's not expressing? Because methylation needs to stay even all the way through. Okay? So the bottom line is if I have this influence happening, then what do I do about it? Okay, so remember, you've got all of these influences here on metabolism. And metabolism cannot be separated from methylation. And I wanted to just get that across to you because now you get to see how complex metabolism is, and you got to see how complex methylation is, which is a segment of metabolism, so integrated in, and then you're actually seeing the genetic controls involved in that. So that's pretty much what we've got going on here with this metabolism and methylation relationship. All right. Anybody else have another question? One person said, what is the, hold on a second, I'm opening this up. What is the correction process for the aggravation of overmethylations? All right, that's an excellent question. The overmethylation process, now with methylation and SNP involvement, when you see a lot of SNP expressions, it could very well mean that you can have two processes happening. You can have an undermethylation process or an overmethylation process, which is known as over is hyper, under is hypo. Now, if you actually have those things happening, you're going to find that there are certain things you got to be looking at in detail. Why am I having overmethylation? For instance, if a person is having overmethylation in their brain, then in the central nervous system, you certainly don't want to be doing things in the gut that might aggravate the brain's balance. Let me give you an example. If a person is having a problem with leaky gut syndrome and they wind up taking a lot of glutamine to heal their gut, that's a wonderful thing. That glutamine actually helps really energize those intestinal cells. However, in the brain, it will actually cause more of a hyperexpressed change in the glutamine, which actually can lead to an overexpression in the brain, which can actually affect the methylation cycle, either hyper or hypo. So one of the things you want to do is you want to be addressing the brain-gut connection. You don't want to be ignoring that. Brain-gut interaction is important. Don't over-excess on glutamine in the gut to heal it, because you might be creating more aggravations in the brain. So to talk about the correction process of these aggravations, it's a very delicate, fine balance. You have to identify possible other aggravating factors that might be occurring, either in the antigen processing system or in the gut itself or in some other areas like that. So find out what the root causes are first, and then begin the process of nutritional replacement, elimination, dietary movement, et cetera, to address those methylations. Now, if you're going to be going to like MTHFR and just focusing on that by itself, that's incomplete. You don't want to be doing that by itself. Is all of the genetic movement, is all of this genetic? Did long-term movement with using antibiotics and long-term use of hormones, can that change methylation cycles? Yes, they can. So long-term antibiotic, because of its involvement, it alters metabolism, especially in the gut, and it can have effects definitely on methylation for sure. The documents that I'm showing will be actually on the video, and I can email them to you. If you enclosed your email, yes, I can do that for sure to get that out to you. I am homozygous for COMT and CBS. What does that mean? If a person is homozygous positive for COMT and CBS, what it really means is that the person is probably having an average hypomethylating pattern systemically. And that means that you can have a lot of issues. happening with that interface between metabolism and methylation. You can have some significant aggravating issues occurring, maybe some areas of the immune system that are maybe hyperexpressing, causing more autoreactivity. Whenever people are coming up with a lot of COMT and CBSs, they usually have some pretty significant challenges with their immune system, as actually been seeing. Those sensitivities don't make it easier for the body to adapt against. So, and then remember this, with genetic sensitivities and susceptibilities, what that basically means is that your genes are what they are. So the human genome at 23,000 plus genes, if you are a zebra with black stripes and a white background, you'll never be a zebra with white stripes and a black background. Okay, that'll never change. But the thing about it is that when you're talking about some of these mutations make you more susceptible to certain types of changes that are not favorable. So like in other words, a COMT and a CBS can definitely affect your detoxification pathways. They can affect how well your immune system performs as a whole. They can actually affect the protection of antioxidant movement and free radicals. So like in other words, you can be exposed to a lot more free radical initiated process and a lot of oxidative damage in the body because these sensitivities are present. To what degree, it's hard to say. And a lot of times there are certain labs you can do to kind of give a good idea. But when we look at your genes and you see these sensitivities, that basically we're saying you've got to shore up these areas epigenetically to prevent, further negative changes down the line. And that's why cancers and neurodegenerative diseases, as well as a lot of the degenerative diseases that occur because a lot of people are not aware of these innate issues that could actually easily be addressed through developing a plan. And developing a plan is the key to that. People are saying, I don't sleep very well, or at least a little. My diet is fairly good. I don't smoke. I don't have any of these bad things, happening that a lot of people maybe seem to have in there. And that is actually all favorable stuff that actually are being said here. But now the point is that knowing your genetics is going to help you to be really on top of your game. It's going to actually give you a strategic map into looking at how the interface and metabolism is happening to a good degree. It's not going to give you intricate details until we get better pathway genomics going on. But you have to remember all of this stuff that's happening here in real time is like it'll blow your mind how fast this is happening in your body with each cell. Each cell regulates all of these points of metabolism. Isn't that incredible? I mean, I just get blown away by just thinking about it. And then when you look at the methylation cycle and you're trying to influence the methylation cycle, you're actually trying to say, hey, I got a lot of potential areas that could be really inhibiting the development of my ability for cells to have healthy generation in the nucleus of the DNA. And that's basically what this whole picture is about. This whole picture basically is saying DNA as a whole, if this is intact, which your metabolism controls, will actually majority develop good, healthy DNA. And that's the bottom line. You don't want junk DNA to be developing. You want happy, healthy DNA to be developing. And that's why you need to know the metabolic integration with methylation. So you can't ignore those two together. If you're having a problem with glucose metabolism, you're having a problem with methylation. If you're having a problem with autoreactivity and inflammation, you're having a problem with methylation. Okay? And you can try to correct the methylation cycle, try to correct that before you do anything else, and you're really not doing yourself any justice if you just try to correct the methylation cycle. Because you got to be looking at the other things that might be stressing the methylation and metabolism. If you've got a significant issue with, looking at lipid metabolism, for instance, a lot of people will actually have problems with being able to regulate their fats. And if you have a problem with cholesterol metabolism, you're going to have a heavy load placed upon your body, and you're going to have a lot of circulating fats that are not really, really happy. And in your system, that causes more tendency to more inflammatory process. So if you have a lot of oxidized LDLs floating around, you have a fault in lipid metabolism. So you'll actually have poor lipid interface, means that you're going to have byproducts in the blood that are not going to be happy. Okay, if you've got excessive amount of glucose in the system, we all know what happens there. Exposure to diabetic movement and pre-diabetes, bad glucose management, bad energetics. I say, for instance, this acetyl-CoA system in this TCA cycle is not working very well. Then you don't have the energy cycle working in your favor. You're not going to be influencing good fatty acid metabolism or lipid metabolism. Bottom line. And then if you look at the amino acids, man, we get down here, you got a whole gang of amino acids that are being manufactured from these first processes of carbohydrates, amino acids, lipids, et cetera, et cetera. So as you can see, any type of areas that we want to shore up, if we've got to shore lipids up, better lipid metabolism, if we've got to shore up better amino and protein metabolism, okay, all of these things, bottom line, will affect development of things like neurotransmitters and brain chemicals that are actually derived from the process of metabolism. Okay, so you see how integrated that is here. Up here, look at this. These are all the neurotransmitter generating areas right up in here. Tryptophan, you see that. The NADH again is part of that pathway. Phenylalanine, tyrosine, all of these different ones that are heavily involved. Look, I mean, if you look over here, and glycine metabolism is very much involved in a lot of amino acid movement as well as neurotransmitter building for your brain. And then again, you got the folate circles that are involved in moving better neurotransmitter activity in all of these different amino acids that are very involved in neurotransmission. So metabolism and methylation are definitely very much integrated. So I hope that kind of gives you a good idea. I'm looking at some more questions here. Anybody else have a question? Someone please type in your question. I'm looking for another question. Okay. Can you still hear me? Everybody can still hear me? All right, here's another question. All right, do we have any double-blind studies on supplements that affect genetic expression? That is a really good question. We really need to do a lot of work right now in creating more double-blind studies to show the results of certain things. I just came across a really interesting study, and it was actually using CoQ10, riboflavin, and niacin in being able to control what they call the PARP1, PARP-1 pathways, which is an enzyme that's responsible for healthy regenerative movement of DNA. And they showed its effect on minimizing mutations in breast cancer. So that question that was asked here about double-blind studies on supplements showing effect on genetic expression, this is a clear example of that, of using niacin, riboflavin, and CoQ10 as 3 key nutrients to decrease mutagenesis, which means mutations. The cells that actually have bad expression are actually inhibited from reproducing because of the replacement of these 3 essential bionutrients. And that, yes, we need more of those double-blind studies. There are some of them out there, but they're very few. A lot of the time, sometimes these studies that are out there are kind of like biased. We need non-biased studies that are out there to show us, we don't want some, pharmaceutical company out there to try to disprove the use of a nutrient. What we want double-blind studies that are going to show us, without any kind of bias, yes, this works, no, it does not work. And I like those straightforward studies. So I thank you for that question. That was really great. Yes, I can get that study for you. What I will do is I will actually forward it to you to your email so you can see it. I was really excited when I saw that because we we've been using riboflavin and niacin and CoQ10 for for inhibiting cancerous movement. And there are some other ones that are out there too, talking about methylation and metabolism integration, especially with regards to cancer treatment. When we actually look at it, there's two other essential nutrients. Maybe some of you have heard of it. There's calcium D-glucarate, and then there's indole 3 carbinol, or known as DIM. A lot of women have been using aromatase inhibitors like Femero or tamoxifen and some of these other newfound aromatase inhibitors. But the thing about it is that aromatase inhibitors zero out estrogens, for instance. Okay, so what is that doing? That's influencing metabolism, right? That's influencing hormonal metabolism. So now what winds up happening there, the people that undergo a lot of these cancer treatments then wind up having some altered metabolic functions, and then they also have altered methylation cycles, which also confuses the DNA further. So whenever you go through conventional treatments, if you do not have the other part of the integrative treatment, it's really harmful, because what it does is it creates a DNA burden. And when you have these cells that are already expressing bad DNA in mutations, and you do not have the encouragement of trying to help with checkpoint repair in DNA, or facilitating better metabolism somehow, or better hormonal balance, these two nutrients, DIM and calcium D-glucarate, work on those estrogen pathways to help use the estrogens appropriately, so that the residual estrogen movement is down to a minimum. So now part of the problem with estrogen receptive and progesterone receptive cancers is not the fact that the cancer cells demonstrate the receptor on their surface. The problem is if there is any lingering negative estrogens hanging around, because those estrogens, if they're not being used metabolically controlled, they are going to be lingering, and they're going to be uptake by those particular cancer cells because of their receptivity. So you wind up having binding of bad estrogens that feed bad signals, and the next generation of those cells that generate. So the next cycle of generation of those cells also have estrogen receptor activity. So that's why the cancers will wind up being fed by, those cancer cells will be fed by the hormone, because you have a lot of lingering hormone around for those receptors to be very active with. So you want nutrients that are going to encourage and facilitate metabolism to get those bad lingering effects, those toxic estrogens, out of the system, so that they do not bind readily to those cells. Okay, so I guess what I'm trying to say is you don't zero out the estrogens. It's not the only. I mean, I don't disagree with the rationale to try to get the estrogens down. But the reason why other cancers are caused by those aromatase inhibitors is because what it does is it creates more mutation changes in other parts of the reproductive system. And so what I'm saying basically is know the biochemistry, know the metabolism, know how the methylation works, try to influence the genetics. Yes, by all means, reduce the expressions that are negative against metabolism and methylation, whatever they may be. And we're going to be talking about those at and more Q&A times. We're going to actually, that's why I broke it all down, because the immune system has its own effect on methylation. For instance, antigen processing. We're going to talk about how antigen processing affects methylation. And you can see some of the other topics that I put. That's why try not to miss any of those topics. They'll be recorded anyway, but you'll find specific information that's going to show you how these areas are influenced big time. So would it be beneficial to get genetic testing from 23andMe? I would say absolutely. The reason why I say that is because you're going to be having around 600,000 bits of raw data that actually going to plot your most susceptible and sensitive genes. And what we do is when you run them through a conversion report, then you'll be able to see patterns and relationships of those genes, those cross relationships that I talk about, and how well, you're going to find out what your strengths are. You're going to find out where your vulnerabilities may be, and there are things you can do to change those vulnerabilities. And if a person has, like, for instance, a homozygous MTHFR A1298C or C677T, any of those particular SNP-related changes in the MTHFR expression, are those significant? Well, they can be. They can be significant because metabolism as a whole is affected. So what you want to be able to do is not just isolate one gene. You want to look at the pattern, and you want to say, hey, I can see a pattern of maybe my cell energy down, my mitochondrial performance down. I can see that the possibilities that I'm developing more inflammatory process by having elevated homocysteine. I mean, these are all things you need to be looking at. Okay, so it's a very important thing. I would say very beneficial to get your whole genome done for sure. Is it better to balance estrogen or eliminate it in estrogen positive breast cancer? As I mentioned before, I would say it depends case by case. I believe that if you balance the estrogens appropriately and get the cells to process estrogen better, that you have a better chance at giving more healthy function and decreasing the likelihood of mutations. If you zero out the estrogens, which we've seen in some cases where I've had numerous cases over the years, 20 years treating cancer, where conventional medicine put the patients on conventional aromatase inhibitors. They wind up, maybe doing better with their breast cancer, but then they wind up developing an endometrial cancer because of the 5+ year use of aromatase inhibitors. And I would say you got to be looking at that because you might have maybe helping with the recovery and remission of a breast cancer, but you might be initiating another reproductive cancer. So I would say better to balance the estrogens and try to get the estrogen use to be more proficient and help with not binding bad estrogens to or hormones that are not being used. So now, if a person cannot do that, I mean, if they have an excessive load where their estrogen and progesterone metabolism, their hormones are just really out of whack, well, then we've got no choice sometimes but to go on an aromatase inhibitor. So you got to realize that's definitely a very, very sensitive question, and I really thank you for asking that. Where can one access the metabolic chart? I can actually get that over to you. I'll share the link where you can actually access it, so you can have that for your use. How do I get tests interpreted? Well, what you want to do is try to go to first, if you have your 23andMe raw data, you can actually go to Health Coach 7. So go to www.healthcoach7.com. We actually do the conversion reports, and you can set up a consult with me or Dr. Jeff Thomas, and we are both we both work in genetics and epigenetics, and I've been doing this for a long time, and I've got a lot of experience with epigenetics and genetics, especially working with cancer and chronic illnesses. And then you can set up a consult after you get your raw data from 23andMe. It's about a 60-minute, sometimes it goes to 90-minute. I'm a long-winded person, so you wind up getting a little extra time for the money you pay. But the thing about it is that you're going to get to know more about your genes, sensitivities, and the relationships. And then what we do is we develop a plan, a recommended plan that you can take to your functional medicine doctor. And if you need to have clinical interface, say for instance there has to be things that happen where you need more testing or you need certain type of prescriptions to be done, we can interface with your doctor, but you would actually have to establish a clinical relationship with us. And that a lot of people do that. So you can do that with Dr. Jeff and myself. We can work clinically to interface with your doctor at home. And we also train doctors, by the way, in how to interpret genetic surveys. So epigenetics and genetics are very, very powerful system of medicine. And I just want to say that I can't say enough. We got a long way to go in being able to understand relationships, but we got a lot of information available to us now with the genetics and epigenetic movement to really assist with some, chronic issues. And I've been working with people around the globe that have been experiencing some phenomenal amounts of improvements. And a lot of people come back saying, I spent, tens of thousands of dollars and I've been suffering for many years. And now I actually have a concrete grip on the patterns in my health because the genetics are actually showing some patterns. So I think it's not the cure-all, but it's definitely It's definitely a very powerful tool to kind of get you to move in that direction. And then you can go to www.healthcoach7.com, healthcoach, the number 7.com, and email at info@healthcoach7, the number 7.com. And I'll type it down here for you. So it's www.healthcoach7.com and info@healthcoach7.com. So hopefully you can see that there on the screen. I put that up so everybody can have it. Anyway, it was a pleasure talking with everybody today. I think I answered all the questions, and I'm looking forward to the next broadcasts here. As you can see on the schedule, we're going to be talking about a variety of different topics in methylation. So we're going to be talking about methylation a long time. So you're going to be methylation experts, and that's great because the more methylation experts we got out there, you can actually tell. You might not be able to go into the intricacies, and because you feel like you don't have a background in science, but you're going to know the basics. And the thing about it is that when somebody can come up to you and say, well, I want you to focus on MTHFR or homocysteine, you can tell them, I don't believe that that's the only pathway I need to be focusing in on. I think I need to be looking at this as a whole picture. Okay, so the thing is that more people do damage to themselves when they start taking supplements on the recommendation of one pathway, or someone else heard some very valuable advice that worked for someone, but it may not work for someone else. I mean, that's one of the things that I get really frustrated about, because a lot of people come back to me and say, if I would have asked first, I probably would have got a better answer to the question. And I agree with that. Now, there's one more question I'm going to take. It's actually, how can I boost my body's ability to assimilate fat? Very good question. You see this metabolism map here again? We go back to the ability of glucose being used as a fuel and moving into what they call the Krebs cycle, or the tricyclic acid cycle, and then being able to generate free movement of energy. And all of this down here are what they call energy producing parts of metabolism. So now, if you are not accessing every part of this metabolism appropriately, and you are not in what they call oxidative metabolism, then you're not burning energy. And if you're not burning energy, which means the available amount, which sugar is the energy, right? You are going to create more fat reserves. Okay, naturally that's going to be the case. So calories in and calories burned equal how aggressive are your workouts. Okay, now say if a person has a resistance, they have an insulin resistance, it creates a very hard process on the body to where it can assimilate fat appropriately. So you can have people that exercise like nuts, and they watch their calories, and they still have a problem with fat retention. Well, with that, a lot of people wind up taking, some of these supplements they call fat-burning supplements that I don't necessarily believe are doing the trick. Some people will go on a ketone diet, which means that they're trying to use ketones as means to burning energy. Sometimes that works. Some people go on a flat-out starvation to lose fat. I don't agree with those processes. Okay, what I agree with is trying to understand how your body is utilizing the glucose. Find out where the faults in fat metabolism might lie, because it could be an issue with a certain absorption of a certain nutrients from the gut that you're not getting. So, people often misunderstand malnourishment does not mean that you're skinny and thin and wasting away. Malnourishment can happen to people that have problems with weight gain too. And it actually can come from the poor movement of water, for instance, in and out of the gut. You can actually have what they call a lot of fluid retention that can actually protect brown fat layers as well as regular fat layers, because you're not assimilating water appropriately and you're not getting the appropriate enzyme breakdown. The other issue is certain trace minerals, if they're not being absorbed, then you're not going to have the cofactors needed to facilitate the energy movement of metabolism. So I don't care how much CoQ10 you're taking. If you don't actually have good trace mineral absorption, you're going to actually have underperformance in your cells, which is going to cause more metabolic lag. Okay. So for instance, people that have a higher FTO, okay, and I know I'm going over here in time, we're getting almost to our time limit. I'm supposed to go to 4:30, but some days I'm going to have to really stay to 4:30. But some days like today, I could go a little over. But the thing is that FTO is a gene control. Leptin receptor is a gene control. Leptin receptor, FTO, MC4R, SLC4A4. These are all gene controls that are responsible for regulating metabolism. So let me give you an example. I came across somebody that actually had an SLC4A4 double mutation, and they had leptin receptor and FTO. And this person has one terrible time of assimilating fat. Okay, if you want to use assimilate as the word. They had a hard time breaking down fat. In other words, they weren't going into using fat as a fuel. Okay, they can't break down those fat stores. Well, what we found out is that this person generally is in an acid metabolism all the time. So, like in other words, SLC4A4, if you look it up on gene cards, it actually talks about the bicarbonate transport ion. And a lot of the times, if you have a faulty bicarbonate transport from cell to cell, it's going to actually cause more what they call metabolic changes to the acid pH side instead of the neutral to slightly alkaline pH side, which then contributes to malabsorption in the gut. And it also contributes to breakdown of healthy lean tissue, but it does nothing to help break down fat. It actually causes the fat to stay. And the reason why that happens is because the body is going into what they call a triple alarm, response, a triple F mode. The fight, flight, fright mode is the sympathetic mode, right? That's actually a stress mode. That's actually when people are actually in a high stress condition all the time, their body is going to try to protect itself from that. And I got news for you. When you have internal changes like this, shift in metabolic control and moving to an acid side, it actually puts the body into a fight, flight, fright movement, because the metabolic movement of an acid or even over alkaline can actually cause the body to think that there's danger impending, and it goes into a stress response. And a lot of the time, you have a lot of fat protecting, a lot of protecting mechanisms that actually protect the body from burning fat, believe it or not. So starvation, yes, you can lose fat. Poor assimilation of nutrients, you're going to have a problem with breaking down fat. So I would say, to answer that question, you can boost your body's ability to assimilate fat by watching your calories carefully, calories in, calories out, okay? Making sure that you're burning them appropriately, making sure that your stress pathways are not continuing in the fight, fight, flight pathways, making sure that your metabolism is being trained to move to keep a neutral pH. Even if you're SLC4A4, you have a tendency to move to an acid pH. Okay, that's a big problem. You can do that by changing, food sources to eat more. I would say alkaline forming foods can help influence that, not to the biggest degree, but it will help because they're healthier foods and they do have higher nutritional value to them. Remove the stressors on your body because that is a huge thing, okay? So that'll actually help with enhancing your body's ability to assimilate fat, and then get on the proper nutrients to help support it, okay? All right. I think that wraps it up for today. So I wanted to say thank you to everybody. Again, you can go to www.healthcoach7, the number 7.com. You can email us at info@healthcoach7.com. Thank you for your participation. We had a good group of people today. We have your email addresses, so we can actually, we'll be posting this next week. This segment will be on next week's website. We'll actually post it on social media, and it'll also be available on Health Coach 7 website. And then please join us for the other opportunities. Next week, I'm going to have to be on the button from 4 to 4:30 because I've got another engagement at 5 o'clock I got to be to. But we'll do our best to really stay within focus on the next topic. And you're going to enjoy the next topic. It's going to show its relationship to methylation. You're going to see some definite patterns and what to look for. And it might help you with solving your health concerns or friends, or and if we have some professionals listening in, it might even help you to help your clients better. So I take questions. Feel free to send those questions to info@healthcoach7.com, and I will get to those as I have a chance. I'll be out of town this next week, so be patient with me. I will get to those questions, and I look forward to them. So thank you so much again, and I'll look forward to seeing you next week. Good night.